Hi, welcome once more to Wafu TV. We are always grateful that you take your time to watch our videos. Do well to subscribe and click the notification bell so that each time we share interesting videos of lessons like this, you will be aware. If this is your first time watching us, this is a platform where we simplify, we exemplify, and we demystify elementary mathematics for your understanding. Last lesson, we discussed about how to solve the different aspects of a triangle, and we also looked at the Pythagorean theorem. We promised you before that we are going to come back to kites and rhombus to be able to apply the Pythagorean theorem to solve the different aspects, especially the side of this shape. Today we are going to look at how we can apply the Pythagorean theorem in a kite, a rhombus, or a trapezium. And with this, if we can find this missing side, we'll be able to find the distance around this shape, or better still, the perimeter. So we'll not waste time, we'll go straight away into finding the missing side of this shape. But before that, it's always good that we remind ourselves of what we want to learn by the end of the lesson. Our objective states that we should be able to calculate the missing side in a kite, a rhombus, or a trapezium using the Pythagorean theorem. So here on the board is our first example, and it says find the missing side and calculate the perimeter of the right trapezium. This is it we have here, and what we are asked to calculate is x. If it is a regular shape, you will have a rectangle, of course, two longer sides and a shorter side. But in this case, we have a very longer side, a shorter side, which are the parallel sides, and we have the height. So we are asked to calculate x. How do we apply the Pythagorean theorem to solve this? Follow up as we go together. To be able to solve this correctly, the first thing is we have to divide this shape into two. So we have here A and here B. Now if you look at A, you realize that A is a quadrilateral, which is a rectangle with a longer side and a shorter side. If you come to B, you realize that it gives you another shape, that is a triangle. And in a triangle, we identify the base, the height, and the hypotenuse. So if we are asked to calculate the hypotenuse here, we have to use the base and the height. But in this case, we don't have the base and the height directly written on it, so we're going to use the dimensions given to find the base and the height. If from here to here is 4, then from here to here will be 4 centimeters. So we have our height as 4. If from here to here is 8 centimeters and from here to here is 5, then the remaining one will be 8 minus 5, which is 3 centimeters. If we have our height and our base, then we can easily find the hypotenuse, which is x here. So x squared will be equal to a squared plus b squared. X squared we don't know, but a squared we know as 3 squared plus b squared we know as 4 squared. X squared equal to 3 squared is 9 plus 4 squared is 16. And x squared again is equal to 9 plus 16, which is equal to 25. So to find x, we simply find the square root of x squared and the square root of 25. So that x will be equal to square root of 25 is 5 centimeters. So we can easily identify this as x equal to 5 centimeters. If we have all this side, then we can easily find the perimeter. Therefore, perimeter will be equal to 5 plus 5 plus 8. This is 8 and not 3 plus 8. Is all along is 8, or you can say 3 and 5. But we use 8 plus 4, which will give us 5 plus 5, 10, 10 plus 8, 18, and 18 plus 4 is 22 centimeters. So this is how simple it can be. It is just to keep your eyes open and see what they're actually asking for there. With this, let's move to the second example. Here we have a second example, and it says, what is the perimeter of this kite? Before we go into solving, let's establish certain aspects of a kite. In a kite, the line AB, line segment AB, is equal to the line segment AD. Also, line segment BC is equal to the line segment DC. If we are okay with that, we move forward. The angle B is the same as the angle D. If this is established, let's talk about the perimeter. To calculate the perimeter, we must know the length of AB, BC, CD, and DA. This is what we have to use to calculate. Remember, the distance given here as 15 is not this line. It's not the line AD. 15 meters here is the line AE, and 6 meters here is for EC and not DC, and 8 meters is not for CB but is for EB. So 8 is here. If we have this, then we can easily calculate the perimeter. And to find the perimeter, the diagonals of a kite separates this kite into 4 triangles, and these 4 triangles have a height, a base, and a hypotenuse. So if we can be able to find the hypotenuse, that is x in this case, and also to find, let's say, y in this case, then we'll be able to find this side, and if we find x, we'll be able to find this side as well, and that the sum of it will give us the perimeter. So let's go one after the other and extract the triangle BEC and solve for x. Triangle BCE. Our height here is 8 and the base is 6. So we are asked to calculate the hypotenuse, which is x. And we know that x squared is equal to 6 squared plus 8 squared. X squared is the same as 6 squared is 36 plus 8 squared is 64. X squared is equal to 36 plus 64 is going to give us 100. And to find x, we simply find the square root of this and the square root of this, so that x will be equal to square root of 100, which is 10 meters. So x is equal to 10. And if x is 10, then this side also should be 10, because this line and this are equal. Let's extract the triangle AEB and solve for the hypotenuse as well. Triangle ABE, we already know this side, which is 8 meters. The base, we already have it here as 15 meters. And our concern is y, which is the hypotenuse. So we're going to use the same formula here. Y squared is equal to 15 square plus 8 square. Y square is equal to 15 square is 225 plus 8 square, which is 64. Y square is equal to 225 plus 64 will be 289. And to find y, we simply find the square root of y square and the square root of 289. Y will be equal to square root of 289, which is 17 meters. So y is 17 meters. And if y is 17, then line AD should be 17 meters as well. And from this, we have this side, this, and this. We have all the 4 sides. Therefore, perimeter will be equal to 17 plus 10 plus 10 plus 17. This will give us 54 meters. And that is it for the perimeter of this shape. Let's move further and to our last example, which will be how to solve for the missing side in a rhombus. Here is our last example. Find the missing side and calculate the perimeter of this rhombus. We have established before that a rhombus is a square because all the sides are the same. That is, A to B is the same as B to C, and the same as C to D, and the same as D to A. We are asked to calculate the perimeter of this shape. Therefore, we need to know the side. Let's name it X. And to find this side, we have to extract the triangle AEB AEB. If we extract AEB and solve for this side, the same number that we have here will apply here, and will apply here, and will apply over there. This is A, this is B, E, sorry, and this is B. The height here is 12 centimeters, and the base is 5 centimeters. So we want to calculate for x. To find x, the rule in Pythagorean Theorem says x squared is equal to b squared plus a squared. So that x squared will be equal to, our b here is 12 centimeters, 12 square, plus our a is 5 centimeters, 5 square. X square will be equal to 12 square is 144, plus 5 square is 25. X square will be equal to 144 plus 25, that is 169. And to find x, we find the square root of x squared and the square root of 169, so that x alone will be equal to the square root of 69, which is equal to 13 centimeters. Remember, this is not our end point because we are asked to calculate the perimeter. If this is a square, then to find perimeter will be equal to side times 4. And we know the side here, which is our hypotenuse in this case. Therefore, side, which is 13, multiplied by 4, is going to give us 52 centimeters. This is how simple it can be, and this is what you can do by applying the Pythagorean rule in solving questions in rhombus, kites, and trapezium. If you picked up something today, consider giving us a thumbs up, subscribe to our channel, and of course, you're free to comment so that we can improve on the service. This is all we had, and next time we are going to be dwelling on circles. This is another plane shape. Don't miss this. And until then, it is goodbye from us.